Hi everyone, my name is Anvita Bansal and we are back with another lecture based on backtracking. So from the series of SDE sheet, it will be the last question from backtracking. So the question is generate IP addresses. So this is a nice problem. Let's see what is this question. Are you guys okay? Fine. So moving on to the problem statement, what you are given is you might be aware of how IP addresses look like, right? So you are given a string containing only digits, any string containing only digits. Your task is to complete the function gen IP, which returns a array list in Java all possible combinations of valid IPv4 IP addresses. Okay, and it takes only a string s as its only argument. A valid IP address must be in the form of a.b.c.d, where ABC are numbers ranging from 0 to 255, and no number can be prefixed with 0. That means there should be no leading zeros unless it's the number 0 itself. So let me explain to you if you're not aware how IP addresses look like. So if you're given string like this 11211, how many IP addresses can you generate from this number? Let me just show you. So what do we have in this case is 11211. Okay, let me just see 1 2 3. Okay, so let's say you have a number like this 11211, right? That's the number you're given. IP, in order to generate an IP address from a given string, so this is a given string to you, you have to generate an IP address. So you have to follow these three things, which are typically that there should be four parts of this string. The string should be divided into four parts. Okay, and each part, now there are four parts of the string, so each part should be an integer. Means we can return it as a string, but if you check what is the value, integer value of that part of string, then that should lie in the range of 1. The range of each part should lie from 0 to 255, both inclusive. This is first thing. Second thing is that the string that you are converting as an IP address, that should have four parts with four different strings, right? Each string should be of this form: dot, another one, then dot, another one, then dot, right? So one string is divided into four parts, 1 2 3 4, and each part should be the integer value of each part should lie within 0 to 255. And third condition is there should be no leading zeros. When I say there should be no leading zeros, this means that you should not have any number as the part of the string which starts with 0. For example, 01, 02, 03, or 034, 034, right? This will not work. If it's the number itself, if there is just like, see, I'll show you the difference of this fourth condition. If let's say you have a string like this 0.1.1.5, okay, so is this a valid IP? Yes, it's a valid IP. If I say a number like this 0.01.1.5, is this a valid ID? No, it's not a valid IP address. The reason is this part of the string has a leading 0, so this is not valid. And why is this valid? Because it's the number itself. The number 0 is valid, right? But a number which starts with 0 is not valid. Okay, so I hope you understood the difference between two. Okay, so now when you are given a string like this, how can you generate IP addresses? One thing that is for sure, so if I check this test case, so what do you have in this test case? You have 4 times 1. Let's check for this. So for if I put a dot here, let's say I put a dot here, so I get a string like this 1.111. Okay, if I put a dot here, let's put a dot here also, I get a string like this 1.1.11. Do you find any of these as valid IP address? No, this is also not valid, this is also not valid. The reason is second condition is followed, that first condition is followed, that range of each part should be within 0 to 255. So if I see this is 1, this is 111, right, and this is separated by dot. So this condition holds true. For this case also, this is 1, this is 1, and this is 11. So this condition holds true. What doesn't hold true is that this string is not divided into 4 parts. So you should have basically 3 separators in the form of dots, which divides the string into 4 parts. Here your string is divided only in 2 parts. So let's check how can I form a string with all the conditions following. If I create an IP address with 1.1.1.1, I think this is the valid IP address, and this is the only valid IP address I can form for given string, which is 1111. Okay, let me check for another case, which is 11211. So for 11211, if I have to put 4 dots anyway. In what pattern can I put those 4 dots? So I have 11211. If I put a dot here, right, then I put a dot here, then I put a dot here, I put a dot here. Okay, I get 1.1.2.1.1. How many parts I have? So sorry, we have to have only 3 dots in order to separate it into 4 parts, correct? Let me just write it here. So you have a string 1 1 2 and another one is 1 1, correct? So in how many ways can you divide this string into 4 parts? So what if I divide this string with, let's say I put 1 dot at this position. Okay, so if I put 1 dot at this position, my string is going to look like this: 1.1211. Now I need to put, this is 1 dot. When I put a 1 dot, now I need to put another dot. So I will be basically having 2 dots in this case. That means my string will be divided into 3 parts. So this is just showing that how many dots I am putting. So not literally, just for your understanding that okay, for this call, whichever call I am making, I am dividing my string into 3 parts because I am going to put 2 dots. Okay, so how many options do I have to put the second dot? So you can clearly see I can put 1 dot here, 1 dot here, or I can put 1 dot here. I cannot put a dot here, correct? Fine. So let's explore all the options that I have. So if I put a dot here, I am going to get a string like this: 1.1, originally what it was. Now I'm putting a dot here, so I'm going to get 1.1.211. What was my other option? First, let's explore all the options from here only. So I have this string. So how many dots were put? Now, till now 2 dots were put. Now I'm going to put 3 dots. So what are the options? I can put the third dot here, or I can put a third dot here. So let's explore the first option. By exploring first option, I'm going to get 2.11. Let's check if this is a valid string. So now wait, stop. Why am I checking at this point only if this is a valid string or not? The reason is, first condition, second condition was that it has to be divided into 4 parts. So when I got to know that the number of separators are number of dots, let's say any variable you are taking. Now I am sure that you are getting a gist of where we are heading to. Obviously this is a backtracking problem. I'm heading towards that approach, and before I move further, I just want to make sure that you can use the brute force approach, which will be typically, even in this, I have not yet told that I am doing this backtracking thing. I am just telling how you can put separators to get your string, right? I'm just telling you the intuition behind the problem. But before I move ahead, you can simply also use loops, which will typically be 3 loops. Start one for I, other one j, other one k, and each loop will be trying to put separator, and basically it will separate the strings in this form. You will have one part of the string that is from 0 to I, other part of the string will be from I to j, and other part of the string will be from j to k, and the rest part of the string will be from k to n minus 1. So this I, j, k will keep on until you reach the you don't get out of bound. So I'm not going to get into details of this approach. The reason is this has already been discussed by at Geeks for Geeks. So I think only this approach has been discussed so far. I don't know if backtracking has been taken. So since this is a very good problem for you to understand backtracking, so let's discuss that approach in this session. Fine. Okay. Moving ahead. So now wait. Now since I know that my number of separators are 3, when I have any partition which is, if I have 3 partitions, then one thing is clear, that I must be dividing that particular thing into 4 parts. Let's say this is one log of rod of 1 centimeter each. If I've put 3 separators, one here and one here, so how many parts of rods do you have? So you have this as one part, sorry, so you have one part, first part, this is your second part, this is your third part, and this remaining is your fourth part, right? So when I got to know that number of partitions are 3, fine, that means now I can check if my string is a valid IP address, check if it is valid IP. Okay, and in order for it to be a valid IP address, I will check that each part or right that I have within the separators, it should lie within the range of 0 to 255, and if any of the part is of length 1 only, then it can be a 0 also, but not for the other cases. So these things I am going to handle while I am making the recursion calls. But from here, one thing you got to know is, in your base case, one of the conditions can be that when your partition index, whatever you are taking, if that index, you can say if my index starts from 0, so when my index reaches at nth, that is n, not n, reaches at 4, that means I have already divided my string into 4 parts. Now if I am making a recursion call, let's say I am making a recursion call from here, so what is the next possibility to put the separator? I can put a separator here, or I can put a separator here. So in this case, I will also increment the count of my separator or index of my separator. So what kind of a string are you going to get? 1 dot 1 dot 2 dot 1 was already there. Now I'm putting one more dot, so I'm going to get this. Do you think this is, we should assess this operation, or we should operate for this call? No, I should not. Even if I made a call to this, I should not go further ahead and calculate the answer for this. No. So this should be one of the conditions for my stop. What should be the other condition? I'll come on that later on. But I hope that you are getting the intuition. The intuition behind is to explore the options of putting the separator, and then wherever you have put the separator, check what substring you have found so far, and if that substring lies in the range of 0 to 255, that's the entire thing we are doing. Okay, so while I was proceeding by putting a separator, I was checking each time what substring I have right now. It was 1, so it was valid. Then I moved to the next part. So this is what I got so far. Now I am trying to put a dot after this. So I am checking this substring, which is just 1. Then when I'm putting a dot here, I'm checking for this substring, which is just 2. Now I cannot put further dots because that is one of my base case conditions that I should not go over. Now what is the next option I can explore? I put a dot here when I had this string. Let's put a dot. So from here I won't go anywhere. Let's explore the option for this string. When I have this string, I put a dot. I will also maintain at which index I am putting the dot, right? Now your index where you put the dot was this index, right? Now let's try for another index, that is I plus 1. Maybe let's say j is iterating over the index at which you are putting a separator. Here your j was at this position 0 1 2 3. Now let's say it becomes 4. Okay, so in original string 1 1 2 1 1, this is 0 1 2 3 4. Now let's say I am trying to put my separator just before 1. Okay, so it can be your, we will see where we will keep the track of it. Right now we did not keep from the beginning. So okay, next option is, if I put a separator here, what kind of a string I'm going to get? I'm going to get 1 dot 1 dot 21 dot 1. Okay, so when I got 21, I have to check if it lies in the range. So this thing I am checking while I'm making the recursion calls, and then I see if it's a valid. I will return it in one of my, I will add this to my answer array list, which I'm going to create. Okay, so this is what we are going to do. If you understood this, how can no leading 0? Let me check. I can't understand. How can no? Okay, let me tell you. See, for example, you have a string like this one. Let me see if you got any example here. See, wait. So I'll tell you about leading zeros. Let me see if you have any test case with zeros. This is a big one. Wait, I'll take the example on my own, don't worry. Fine. See, so let's say you are given a string like this, 1 0 1 0 2. Okay, so this is your given string. What are the valid IP addresses that you can form from this string? So you basically have to divide it into 4 parts. Let's say if this is one of the strings, 1.0.1.02. Okay, first of all, tell me, is it a valid string? Let's check. For this to be a valid IP address, each part should be within 0 to 255 range. Okay, so if I check about 1, if I see 1 is a valid part, 1 is valid part. Is this a valid part? Yes, it is also a valid part, because I can include 0. If the entire part itself is of length 1, then this 0 is valid. This is valid. Then I have 0 2. Now you see this part, which is 0 2. Is it of length 1? No. It is of length 2 with a leading 0. So I cannot take these numbers. Do these numbers lie in this range of 0 to 255? No. That is why such a string will not be valid. What can be a valid string? If I divide this like this, if I divide the string into 10.10.2, is this a valid string? No. Actually, you will realize that I think we will not be able to find any valid string for this test case that I have written. I'll tell you why. Now if I try to make a IP address like this, is it a valid string? The reason is no, because the string is not divided into 4 parts. My first condition is not first, second, third, but one of my conditions is that it should be divided into 4 parts, right? If I write 101, if I write it like this, then I can find a valid string. I put a dot here, I can find a valid string. Is there any leading zeros? No. What if one more possibility I can make from here? There are more possibilities, but to show you, I can make it like this: 1.0.102.1. Is this a valid IP address? Yes, this is also a valid IP address. The reason is it is divided into 4 parts, and each part lies within the range of 0 to 255. Okay, so I hope this point is clear to you. If you have any doubts, you can ask me. Fine. Is the video lagging? I hope it does not. I think the net is not too good. 1 second. Fine. Moving on, what we can do. So what is happening in recursion? Just a second, I think it's okay. So let me just write the code right now so that you can understand what is happening. Then I will do a dry run. So let's start with it. If I start with it, I told you have to explore options where I can put the separators, and then simultaneously I am generating the string, the final string, because I have to return string like this. So let's see what I'm going to do here. Let me write another function, helper function of type void, public void, in which I am going to pass the parameters. Let's see what parameters. Public void gen. Okay, this is the name of the function I'm giving. So I am passing the string s originally, that is given here. Okay, then int idx or I, int n, which is the length of your string. I will tell me at which position I'm trying to divide my string s. Okay, so that is that index. Then I am taking int partition. What is the count of the partition? If my partition reaches total 3, right, then that means you have divided your string into 4 parts. So I'll take it like that, and string this temp will be the string that you are going to generate, which will be including dots. Okay, fine. So, and also you will be having an array list of type string, which will be a list of all the possible strings. For example, this was your test case, so there should be an array list which should contain all the strings of these types, which I will finally return. So let me mark it as answer or result or whatsoever. Fine. Now what? We will come on the base case condition later on. First, let's check what I am doing. So what I am typically doing is, for I and t, let's say your k, okay, it starts from index I, and k can go till I plus 3. This tells me that I am first putting a partition at ith index, then I plus 1th index, then I plus 2th index at max, because I can put partitions how many times? Total 3 times. Fine, this tells me this. So obviously when I'm going till I plus 2th index, I have to check that k is always, remains within the bounds of your string, which is the length of your string. So k should also be less than n, and then you are doing k plus plus, incrementing the count of k. While I am doing so, what am I doing? I am checking each possibilities at which position I can put the partition, right? I will explain it when I do a dry run, so you will be very clear with what is actually happening within the call. So next thing what I'm going to do, I have to, let's do one thing. I create a string, let me take current. Okay, string current. So string current is nothing but it is s dot substring from I to k plus 1. Now what am I doing? So I am assuming that there is some string like this. Let's say I have one string like this, 1 1 1 1 1 1. Okay, so what am I assuming? If my I is equals to 0, so I'm assuming that I have put a dot here. Okay, I have put a dot here. So what is the rest of the string? I have to check that. What is the rest of my string? So that the rest of my string is from, typically it is what, I plus 1, I 2. What they are doing, I was initially 0 and right now your k is also 0. So I want to check that what is that part before which you are putting that partition, right? So this is what we are doing. I am passing my temp initially, the temp string initially as an empty string. I want to generate this string now. So one dot has been added, and this dot, let's say I start from 0th index, so I have to make sure that what is the remaining part of the string. Since I have started from k equal to I, and I can put this partition once here, once here, once here, once here. So what is the remaining string? That I am keeping track through current. Okay, fine, moving on. So I am okay. Next thing is that I will check if this s dot char at I, okay, if this is 0, if that index is 0, also you have to check that cur dot length, it is greater than 1. Fine, which means if your current, the substring which you are trying to partition into, so this current is that partitioned substring. Okay, if that substring's length is greater than 1, which means minimum of length 2, and it has 0 at the starting index, correct? So this tells you at I is the starting index of that substring. So at I, if I find a 0, that means there is a leading 0, which I do not want. There are other conditions, so this makes that string invalid. And what is the other condition? That if it lies within if it doesn't lie within the range of 0 to 255. So since it is of minimum length is 2, so there is no point of checking if it is of a unit digit number. I just have to put a check if your cur integer dot value of this cur, if it is greater than 255. In that case also, if any of these conditions hold true, and this is your See, this altogether, this is checking if you have a leading zeros, and this is checking if the substring that you are checking is greater than 255. If that is the case, just simply return. You don't want to make any recursion calls. Otherwise you are making a recursion call. You are making the recursion call for what? You are checking your s will be as it is. What is your index I? So index I will be k plus 1. Why? I will tell you. First, let's see what is happening. Then this is your n will remain same. Partition will be increased by 1, as I told you while I was doing it on the board. Then you will have temp. This is the string that you are creating. Okay, you are trying to create this string. So this string will be what was your original string? That string, right? Then you added a dot. Okay, then you added a dot. So add that dot and add the remaining part of the string which is stored in current. Okay, so plus current, and then this array list which is res. Okay, what is the base case condition? Now see, the base case condition is if your which index is iterating over the string s. I is iterating over this s. I start my I from 0. Let's say I'm passing I as 0. So if I becomes equal to n, I is equal to n, and I told you partition becomes equal to 3. Why? Because I am passing, initially I'll be passing partition as 0. So maximum it can go is till 3 only. 0, 1, 2, 3. So in terms of index, or okay, you pass it as 1 and make it 4. Par becomes equal to 4. In that case, you are passing partition as 1. Then what? Then first of all, you are adding that string what you have got in temp into your resultant array. So res dot add temp, and then you return. Fine, and then you return. Now just make this function call from this gen IP function. Before that, let's create array list of string arr new array list. Okay, next thing is int n is equal to s dot length. Then make a call to gen function and pass the right arguments. So string s is passed as it is, starting index is 0, n is, you have already defined n. Then partition, you are starting from 1, which tells me that you are starting with 1 partition, and then you are taking a temp which is an empty string, and resultant which is arr here, and then you are returning arr. Let's check. Array list of new array list. What is the issue? This is the issue, capital L. See, okay, so what is the issue? You have to add temp dot substring 1. Don't worry, I will explain everything. Now what is the issue? Okay, it is adding lot of times. So let me check what is the mistake here. Is it not checking? So these are not valid strings, you know that. Why? So I have to also put a check. Why? Let me see what is the issue. So k should be, that is fine, and k is an I. Fine. I is k plus 1, 0 s k plus 1, n partition plus 1. Temp is this, partition is 4. So let me see if I am okay. That was not right. Let me check. That was the partition handling issue. Let's submit it, then I'll move to the outro run. Fine. So this passes. Now let me take this code and help you understand what is actually happening. wait. Okay. Fine. So this is the code that we have written. Now let's see from an example. Let's see the recursion tree of what is happening if I take your we will understand it with the recursion tree. So this is your code. Let's say I am doing the thing for 1111 4 times 1. This is a string that I have been given, and this is your gen function. Let's say this is your gen function, correct? Okay, so you start with 111 and you are passing, what is the initial thing that you are passing? You're passing gen of generate function, in which you are passing your string as s is 1111. Fine. What are the parameters that you have to pass? One I. What is your I? Initially it is 0. What is your n? N is 4. Next thing, your partition, initially you are passing it 0. Next thing, your temp and resultant array. So temp initially is empty and resultant array is ARR. Okay, fine. Let me write, this is your string s, this is your index I, this is your n, this is your partition, this is your temp string, and this is your resultant. So what happened? You checked for base case condition. That is not true. You move to this for loop. So in this for loop, what is happening? See, what is happening in this for loop? You are starting your k from ith index. So k in I is what? 0. So right now your k is 0 and you are checking what is your current string. You are extracting a string which is s dot substring starting from I till kth index. K plus 1 is exclusive, you know that, when we take a substring. So I is 0. So 0 to 0 is the substring that you have to take from s. So right now you have 1 as your substring. So current is equal to 1, right? Because from 1 1 1 1 0 to 0 substring is this part, correct? Okay, so what does this mean? This is telling me that I am trying to find that substring before which I will be putting my partition. That is the intuition behind it. Okay, so next thing, I will check if this 1 is valid or not. So this 1 is valid. Okay, if it is valid, then I go and make another recursion call. So your next recursion call will be for generate function. Your next recursion call will be for generate function, which will be making call to string as it is. The things which are constant, I am not writing that. Let's write what is all changing. So your k was 0 here, right? Your k was 0 here, and k can go maximum till k plus 1, k plus 2 and k plus 3 indexes. Why? Because at max for one particular position I can do 3 partitions, right? If I have 1 1 1 1, so if I am doing one partition here, let's say this is your one partition. This simply means if I am doing one partition here, the remaining string I have is this. If I do one partition here, the remaining string I have is this. So if I do one partition here, the remaining string I have is this. So if I do one partition here, the remaining string I have is this. So when I am doing partition, what is the string that I am left with? This is what I am storing in current, correct? Okay, so where I am doing partition, that I am handling with index k. So you are making a call to gen function with I as k plus 1. So k was 0, now it will become 1. Next thing is your partition is also increased, because here your partition was 0. Your partition was 0. Now your partition has become what? 1, because this tells me that I have already made one partition. Now tell me what is the next possibility. Fine. So 1 1, and your temp becomes what? See, your temp will be originally what it was, right? And then you have put a dot into your temp after it. So it will be this dot, and then whatever current string you have, that means before which substring you have put dot, you are going to add it. So basically you are generating temp starting from from 1 1 1 1. This means you put a partition here, so you are left with this part of the string. Okay, not left, so the string before which you have put the partition, that you are adding into your temp. Okay, so right now your temp looks like this. And next, so here you know what you have k as 1, your partition as 1. Your base case doesn't hit. Now you again try and do the partitions for the next part of the string, which is you have 1 1 1. Right now your index, initially it was a 0, now your index is at this position, idx is at 1, or whatever I you have, your I is equal to 1. That means you are going to put a partition just before this one. So when you put a partition just before this one, you are trying to check what is the substring you are left with. So your current will say you have a substring from I to k plus 1. So your I in this case is what, 1, right? And your k was also what, 1 only. So this substring will be 1. So this tells you that you will be in your temp. So you are making a call to gen function, your I will be increased by 1, your partition will be increased by 1, and you have a substring, what, original substring dot 1. Then you made a dot, you put a dot, and then you added the remaining substring, that is 1. So now you have dot 1 dot 1. Fine. Okay, make next call. So the next call you have is gen function. In gen function, what is your I? Your I becomes now 3, correct? Your I becomes 3, your partition becomes 3, and what is the string that you're going to have? You had 1 1 1 1. So I, your k was also 3, right? And your I was also 3. So since your I was 3, see, your I was what, 3, so you start your k from ith index, so your k is what, 3, and you take a substring that is ranging from I to k, correct? So third index value will be taken as current, and that means you are putting a dot just before this string, and this will be added. So initially your temp string was this, now one more dot is added to this string and one substring is added, that is 1, right? So this is your current temp substring. Now make another call to gen. Till now you have not hit the base case. Now your index I becomes 4, your partition becomes 4, fine. And when you were at this index, your I was, when you passed I as 3, from here when you passed I as 4, okay, let's see, when you passed I as 4, right now actually you have this base case condition. What am I missing here? Dot 1 dot 1 dot 1. Okay, so you are operating over this, and the substring that you will generate will be dot 1 dot 1 dot 1 dot 1. Now when you make a call to gen, actually you are, now when you're making a call to generate function, your I will be 4 and your partition will be 4. And what is the length of your string? That was 4. So when your length of string was this means that you have found a string with all the 4 parts, right? And now, but the state of your string is of this type. Why? Because I am adding dot first and then the remaining of my string. Fine. This is the reason when I am adding into my resultant array list, I am doing temp dot substring, which is dot 1 dot 1 dot 1 dot 1. So this dot is at 0th index, so that index will be that index string or character will be removed, and you are simply storing the remaining part of the string, right? So that is just this one thing. Now when you see, now you hit the base case, you return. So you return back to which call? You return back to this call. You will see, is there any other possibility? Actually for this string, I think it should be like this, okay, and here itself you have dot 1 when you make a call to 0 0. Okay, so when I'm passing, you will see for this case you will have no more possibilities. If you might have, so what will you do? You will increase your k starts from I, but k can go from, let's say your I is 0, so k was initially 0, now your k will be I plus 1, your I is still 0, your I is still 0, but your k is 1 now. Okay, so what is the substring you are taking? What this means is that you are putting a dot here, but the next dot that you will put will be after 1 1, right? This is what this formation of string tells me. When I put a dot here and I am taking this substring in current, this tells me that next dot I will put will be after this substring. Okay, so dot 1 1, and this is what I have in my temp, okay, and then I make a call. So when I go ahead and make a call, I possibly can have dot one, and dot one is one of my strings, but you will see that it does not have four equal parts. So my partition will actually never reach equal to 4. This is the reason I will never hit the base case condition. So this will never be added into my temp dot substring, right? And this is the, so that's how you are handling the cases. So if you have any doubts, you can ask me. If you have no doubts, then we will wrap it up. So with this loop, starting from, let me take one more example. For example, you have 1, 2, 3, 4. So the kind of strings that you can have from here will be 1.2.3.4. Other possibility is, let's say I have 5 also, 45. Other can be 1.2.3.4.5, and all of these are valid. How am I checking what is happening here? See, let's say one last example, 1, 2, 3, 4, 5 is what you have. You start to create a substring when, let's say, your I was 0, your partition was 0, okay. Your loop which says your k starts from I and k is less than what, I plus 3 index. Simultaneously you will check that k is less than n also, because you are making it go till I plus 2th index. So when your I is 0, I is at 0th index, this is I, your k is at 0th index. So this tells me that I am adding a dot just before 1, and I am taking this as my current substring. This is my current substring, which means the next remaining substring that I have will be 2, 3, 4, 5, okay. In short, I am, what options I can have, I am putting 1 and then making a recursion call for 2, 3, 4, 5, and then this 2, 3, 4, 5 will say that okay, you take a 2, put a dot and make a call for the remaining part of a string, that is 3, 4, 5. Then 3, 4, 5 will say I can have a 3 dot and make a recursion call for remaining part, that is 4, 5. But while you are doing so, you are adding your answer to your temp. So your temp right now is going to look something like this, dot 2, right? Then next thing will be dot 1, dot 2, dot 3, and then you are making a recursion call for 4, 5, right? That is what is happening. So now you have, what you have next is, you take 4 and call recursion for 5, okay, call recursion for 5. But right now the string that you will have will be dot 1, dot 2, dot 3, dot 4, and then you are making a call for 5. But you cannot include 5 with dot now, because your part of strings will exceed 4, your partition will exceed 4. 1, 2, 3, 4 I have already done, you cannot add one more partition, so this case will be rejected. So you check and make a recursion call. What do you do now? You do one thing, that so far you had 1.2.3, so you made a recursion call for 4, 5 where you put a dot after 4. So let's do one thing, put a dot just before 4. That means your I is basically, you take k starting from I. Now your k has become I plus 1, okay. So that is what you are checking, it becomes here. So when your k is at I, you take only one substring, that is from I to k. Now you take a substring from, when your k has become I plus 1, that is at this index, you are taking I to k, so this substring will be 4, 5. So this 4, 5 when added to your temp, it will look like this, 1.2.3.4, 5. So I hope you understood. So this is one of the valid substrings, because number of partitions are 1, 2, 3, 4. So when I am adding in my base case, when I'm adding it, this is the reason I am doing dot substring 1, because this will remove this dot and I will be left with 1.2.3.45, right? So this is about it. So try to attempt this question first, try to understand this question on your own, okay. Even if you don't, you can come at this video, understand the logic, then draw the recursion tree. First of all, you need to understand the recursion tree first, and then you can move to the code, okay. So that is all about it. Let's wrap it up then. See you all in the next lecture. Next lecture onwards, we are going to start bit manipulation. We are done with the problems of backtracking. So thank you everyone, take care, bye bye.